Hello, curious human. I don't know if you ever looked into the technical specifications of a climbing rope, but it does have a lot of mysterious numbers that I think are there just to confuse the new climbers. And then it has a lot of seemingly obvious things like diameter, length, weight. However, if you try to measure them, and I have tried that many times, you will never get the numbers that are declared. So I had two goals for this video. The first one was to visit my nerdy friends at Mammoth.
Welcome to the world of destruction.
Welcome to the world of destruction, she says. And see how every parameter is measured in the lab and what those numbers actually mean. And then I got curious, is there any difference between different ropes? Meaning if I take 9.5 from one brand and then I would take 9.5 rope from the other brand, will there be any difference in technical specifications? Or it's pretty much all the same nowadays. So I ended up scraping the internet and collecting specifications of hundreds of climbing ropes and then building correlation charts between different parameters. So yeah, all with the goal to make you a bit of a climbing rope nerd, or nerdess. The Holy Bible standards. So you follow the Bible when you do the testing?
Yes, this is actually like a short version.
Short version?
Yes.
You even add underscores, like so geeky.
Yeah, that's... yeah,
Instead of space, you just add underscore dash. Yeah.
So I have here a classic report, an internal report, in which we have to provide numbers for a construction, the diameter, the weight of the corp, and the weight for the sheath. And then, of course, we sum it up, and then we get the weight per grams per meters.
Okay, you're overloading me already. Let's go one by one.
One by one. Construction test.
Construction test. What is that?
So construction is a number that will be tested that the consumer will never see.
I just make a Prozik, and then I slowly let the weight in.
So you just put now 10 kilograms?
10 kilograms, and then now we should wait for a minute. But in the meantime, I can explain you. You say, okay, I want to start from here. Then you follow a straight line. You come back to the same pattern, and you do this 5 times. 1, 2, 3, and 5. Certified ruler. My minute is almost done. So now I can take my measurement. This is 17 centimeters. My construction will be 17 centimeters divided by 5, 34 millimeters. This means that every 34 millimeters, we have a repetition in the
pattern.
In the pattern, exactly.
The smaller the size, that means you have more material on the same surface area. So if you have more material on the same surface area, it gets more stiff. If it's more spread out, that means the angle of the twines is a little bit more steep. Mm-hmm. Then you have less material on the same surface area, and then it's softer.
So are you aiming to have more material in the same, or it's a balance that you're playing with?
You're trying to get the best hand feel for the rope. Mammoth ropes, for example, are usually known to be a little bit stiffer. Mm-hmm. So we know what kind of construction we need to make in order to achieve this.
This is actually very interesting. If you compare dynamic ropes from different brands, you can feel that some of them can be very soft, while others can be much stiffer. Unfortunately, as Adriana said, I was not able to find any brands listing construction on their data sheets. Petzl does have a property named construction, but what they actually list is the number of bobbins that were used in the making of the rope. So it's a different parameter, which is also very rare to find on specifications, but the more bobbins used, the smoother the sheath of the rope is gonna be. The cubicles that make the rope will be much smaller, which creates less friction and should increase the durability of the rope. But back to the softness of the rope, personally I would like a UIAA soft test. Unfortunately, currently we only have one test which is somewhat related.
Next test.
Next test. It's called Knotability test. It's part of the static rope test, but we do it anyways, even for our dynamic ropes. What we have to do is make a simple overhand knot. So they are both overhand knots. They are opposite, they're mirroring each other. 10 kilograms, let it sit gently for a minute. We have this Harry Potter wand.
Harry Potter wand. Do you know any spells?
Wingardium Leviosa.
Oh, that would be useful for climbing.
Yeah, lift myself up to the next bolt. Then I gently take out. I only leave the 1 kilogram. And now, without putting pressure, I need to make it go in. So here is roughly 7. Here I go 7.
So knotability is a ratio between rope diameter and magic wand penetration. The smaller the number, the softer the rope is. But it's rare to see manufacturers providing this number for dynamic ropes. So if you are particular on how soft you want your rope to be, unfortunately you will have to go out into the climbing shop and touch. Oh, next one is my favorite one, diameter.
Diameter, exactly.
I've tried to measure this so many times and it's a wild west when you measure it. So show it how you arrive to 9.5.
Okay, so 9.5, 9.8. I have to measure within 1 meter of sample. Of course, there's always a tolerance. Now I get my caliper with the special flat edges.
Oh, it's a different caliper.
Yes. Now I have to take 6 measurements. I'm not trying to squeeze to get my number, but without putting pressure, I need to go around and see where it's maximum. It should be here, 10.03, and then I can turn 90 degrees, 9.8.
So you found the thickest point in that spot and the thinnest, and you take the average of that.
Yes. Then here I do the same, 9.84 plus 10.03. 9.82. So I divide everything by my 6 measurements. Then I get a 9.95.
And what was it supposed to be?
9.8. So
we are 0.15 over.
Yes.
So something to know is that by standard, we have a 0.2 tolerance for the diameter.
So every rope I buy
as a plus minus.
Yeah.
It's to factor in the various steps of production, which you cannot control down to the 0 millimeter.
So basically whatever goes on the package is plus minus 0.2 millimeters anyway, measured in preloaded way.
Exactly.
So that's why pretty much every time I try to measure, it is way more.
So no point in doing this at home.
Well, now we know.
Now you know how, yes, but also all the samples would need to be climatized at a certain temperature and humidity percentage.
So we put it in that big cabinet over there, which keeps 23 degrees and 50% humidity. And technically, this test has to be done within a certain time upon removal. 1 minute to hang the 10 kilograms. Then within 1 minute, you had to measure the construction. Within another minute, you had to measure the diameter.
So you're running from there to here.
Yeah, I try to be fast.
Okay. And you know what always fascinates me? How such a small change can make such a big difference. If we compare 9.0 rope against 9.5 rope, you will feel a big difference. However, at the same time, it's only 0.5 millimeter difference.
Now we can do the weight per meter. Don't need this. I'm going to cut on the same side of the pin I put in, just to factor in that bit of... okay, and also here.
So this is 1 meter if you put 10 kilograms.
Yes. And then here what we do is we take the core out and measure it. And also, as you can see, this is another really precise scale, if I go like this, it changes.
So basically just a little bit of wind does change the reading.
Yes, exactly. Now I do the sheath weight.
Now, in rope specifications, you will always find combined weight per meter and sheath percentage. However, if you want to know the total weight of your rope, multiplying weight per meter by the meters, which seems obvious, is not gonna be accurate at all. First, as you saw, their meter is taken from the loaded rope, but also manufacturers package 2 to 3% more length of the rope than what they declare on the package. And that's done because ropes have a tendency to shrink over time, so manufacturers are being nice to us by giving more of the rope. Now, obviously, there is a clear correlation between the diameter of the rope and the weight, but what is interesting is that the variance can still be very big. For example, there are 10mm ropes that are lighter than some of 9.5 ropes. Now, personally, I'm not a big fan of chasing the lightest and smallest in everything, but if the weight is a big factor for you, you might be entertained to know that multiple brands claim to have the lightest double rope on the market.
Next test?
Next test.
Sheath slippage. It's not exactly.
So this is your favorite room?
In summer for sure, when it's really hot. So now this end is open, and this one is sealed, because I cut it with the heat cutter. Now I can explain you what this is. Exactly. This very simple, let's call it machine, is defined...
This machine is called machine?
No, it's called sheath slippage machine.
Oh,
Sheath
slippage machine.
Exactly. So what we're going to do here, we have this 3 5-kilogram weights, and we're going to engage them. So now this one is pulling, this one is pulling, and this one is pulling. So now in here we have 3 standardized bolts, and they're pulling on 3 different directions. So one is pulling this way, this one is pulling this way, this one is pulling down. What I have to do, I have to pull it until the end comes within these marks. That's why I have my, my mirror here, so I can check.
Wow.
So I can start. And it has to be a continuous speed, and I'm there.
So you pulled the rope with some pressure from 3 sides towards the rope.
Yes.
And now you reset and pulling again.
Yes. And I have to do this 5 times.
So it's basically a rope squeezer.
Yeah. Number 5. As you see, I've never touched this part, right? I was always pulling and pushing from this part. Now I slide it back again.
You're talking like a magician, you know?
Of course. Houdini.
As you see, nothing happens here, and now look, poof, magic.
Now you can actually see here, exactly where we had our mark, the sheath hasn't moved.
He really sounds like a magician now. You want some poof?
Trick number 1. No, this is actually something I really, really like. Sheath slippage, 0. That's why we declare 0. So what you could expect usually is to have your core to be, now it's just out. And then you would have to measure like this. This will be 6.77 millimeters. And this we will call minus 6.7 because it goes out.
So what I had happened where I cut the rope, even though I burn the end, but maybe I don't burn it very well and I go climbing, and sometimes some of the core starts coming out.
Yes.
Is this related to this?
Yes.
So with this rope, which is declared as 0 sheath slippage, the core would not start coming out of the rope?
If one end is sealed.
If one end is sealed.
Yeah.
And if both ends
are
were
open,
cut?
then the core is free to move. It's like a snake in a tube. It just goes back and forth if you want.
I've done this many times. I still sometimes find it difficult to burn the end well. You might burn a little bit and there is still visibly big holes. Then you start burning more, then it all goes on fire and then the big clump happens.
Yeah.
Well, what I do sometimes, but this is
Heat the knife?
No, I use a stove. You make it really hot and then try to tension it as much as possible, and use the bars going through the the gas burning. Use that one as a knife.
Ah.
So it will look like this.
And then you have that
kind of
fume of plastic coming out of your stove for how many days?
That's not safe, maybe, because you're burning plastic. But
This is not a Mehmet recommendation. This is a
Tommaso
Tommaso recommendation.
Okay, now when it comes to sheath slippage, unfortunately, not all the brands list that information on their websites. And in some cases, they list only on some of the ropes. So if it's 0, they list 0. If it's not 0, then who knows? And according to the standard, this information should be on the packaging. However, if you're shopping online, then good luck knowing.
now we have to do static elongation. So these are reflective tapes, and I'm putting it just a little bit above my clamps. One at the bottom, one here at the top. Now, sorry, I go in. Only while the machine is not running, just because I have to...
Play with lasers, of course.
Exactly. I can start.
Only while the machine is not running, he said.
So it went into a pre-tension phase, and now I need to check that the laser is actually in place. So it read the first one because you saw it stopped and beep and blinked. Now we'll reach the top one and blink again. Let's just close this one. So as you can see, the lasers are going up.
So your markers are going up and the lasers keep following them.
Exactly. And we have our holding time of 3 minutes.
And it keeps holding exactly 80 kilograms as the rope is relaxing, it keeps pulling more.
That's why you can see here DL, elongation of the sample, compared to the starting position.
Yeah.
See, it keeps increasing.
So if I stand here and the laser misses the marker, it shines straight to my eyes.
Yeah. And then you get to stay home from work.
Why are you smiling saying this, Tommaso?
Okay, so machine completely relaxed.
Yes.
And your lasers went down.
Yes.
And you got the results.
5.71%.
So static elongation is basically imitating you sitting in the rope or taking a top rope fall. And for most dynamic ropes, it's between 5 to 10%, where 10% is the maximum allowed by the standards. Let's say you want to top rope a 30 meters long route, and the climber takes a fall close to the ground. So we have total 60 meters of rope in the system. Let's ignore all the potential zigzags, friction, and maybe slack. And let's say that we are using a rope with 5% of static elongation. So such fall would stretch the rope for 3 meters. But if our static elongation would be closer to 10%, then the fall or the stretch would be up to 6 meters. And that would be really bad for top roping with such rope. At the same time, it would also be a bad rope for projecting, because every time you would pull on the rope, you would be just stretching it like a rubber band. But I'm gonna come back to this topic after we see how dynamic elongation and impact force is measured.
So yes.
Welcome to the fancy drop tower.
Exactly. Super fancy that it's all kind of automatic.
I see it's doing its thing and you're doing nothing.
Yeah. Yeah.
Besides running up and down the stairs.
So now I basically just went up, checked all the positions. Now I have to tie in the sample, secure it, 1, 2.
So there is no knot at this end?
No.
So it's friction, but in the end there is still some kind of clamp.
Yes. And what we do here with these 3 turns is to not have the force of the fall absorb here.
Yeah, because it would break at that spot.
Exactly, it would just basically choke it and cut it. So our goal here is to simulate a really high factor fall. For example, you're multi-pitch climbing and you start off, you always, back up at the anchor because you don't want to fall directly into the belay device.
So this is your belay device, then the rope goes to the anchor, and then you take 2.5 meters.
Yeah, more or less.
And then you climb all the way above it.
Yeah.
And you take a massive whipper, and you are a steel mantis of 70 kilograms.
80.
80 kilograms steel mass.
Falling in a freeway. There's no friction, you don't slam in the wall, so it's falling vertically.
Yeah, it's preloading.
What just happened?
We tied the top. I did an 8 knot at the bottom, and now we are elongating the rope. 80 kilograms are sitting in the rope and just, you know.
Okay, so before the drop, it's already
elongating
loaded.
for 1 minute. I usually say that this kind of activates the rope. My minute was gone, and now it's going back up. Opening again the clamps, because now we need to calibrate to measure the exact length.
So at first you put some weight on the rope so it stretches to a certain degree.
Yeah.
And only then you are calibrating the length.
Yeah, so now I put this tumor, then I let 10 kilograms in. So by doing this, we make sure that from here to there will always be the same sample length, but it's not like I am pulling here to get it as tight as possible, and then comes another tester, and they maybe pull a little bit more than me, a little bit less. Then here I'm just basically doing a mark with my Edding 3000. And I'm not sponsored by Edding, but it's just this is the marker that you need to use for your ropes because it doesn't hurt them.
It's very important to mark the spot to see that the rope remained in the same position, because if it would slip somehow, then you would always deliver more or new material to the deflection edge, and you would get...
because you are trying to hit always exactly the same spot in every fall.
Yeah, if you have a rope slippage in the clamp, then it's an invalid result.
So now what? It's hanging again.
Now it's hanging again. And
I thought you're just gonna drop and that's it.
No,
but
no. It's very
entire preparation procedure.
And now this is actually the most important part, because after this one, we will read exactly the sample length.
So the machine takes a measurement of the length.
Yes, down to the 0.1 millimeter.
So now it's just gonna go kaboom.
Yes.
Oh man, that's a big whipper on this. Like, okay.
So now this is our rope, as you see.
Yeah.
It's like completely going up. You see there's no stretch, right?
Okay,
there's
so
no
pretty much
wiggle room.
all the rope that you had is going up there.
Yes.
Wow, that is like still a big bang. Big bang.
Yeah, imagine when it rips, then it's a real big bang.
So we had 30% elongation, and max force was 8.085 kilonewton.
All right, let's start with elongation. I thought that a stretchy rope is a stretchy rope, meaning that if it has high static elongation, it should have high dynamic elongation. And while there is a correlation, at the same time, there are ropes with high dynamic elongation but low static. And there are ropes with high static elongation but low dynamic. Interesting.
And actually, what it is really interesting to see is this one. That wasn't there. 20 centimeters maybe, 15 centimeters
Yeah.
of just, elongated rope. Now we have a 5-minute waiting time, and a little bit of this elongation will go back into place. But some part will stay, let's say, stretched forever.
Now, the second parameter we got from the first drop is the impact force, which according to the standard should not exceed 12 kilonewtons. But most ropes nowadays will be between 7.5 to 9 kilonewtons anyways. However, Beal stood out with a lot of low impact ropes. So I was wondering why. And the answer becomes visible once I plot elongation versus impact force. Turns out they make much stretchier ropes. So if you make a rope which stretches more, obviously that helps to reduce the impact force. However, as I already explained, more stretch is not always better. So a perfect rope should minimize both elongation and the impact force. Now, since I have this huge database of rope specs, I got curious, so which ropes do have the lowest elongation and impact force combined? I filtered out all super skinny and super thick ropes, since I don't like them, and voila! A list of ropes with the best dynamic properties on paper. Now, are you gonna feel the difference if your rope is 10 to 20% softer? Would be interesting to do maybe some human testing to figure out, but the big elephant in the crack is that all of those specs are taken from the first fall only. Who knows how all of these ropes are gonna perform after hundreds of falls? Maybe softer ropes are gonna lose their dynamic properties even faster. Unfortunately, at the moment, there is nothing in the standards that would test long-term performance of climbing ropes, which is sad. So UIAA. But let's continue with our tests. After 5 minutes rest, we have another drop. And this rest drop process is repeated until the rope finally breaks.
You already see this is like a super harsh condition. This is something that even in reality is hard to replicate. And then in this test scenario, we do this drop over and over again, only with a break of 5 minutes in between drops. So the rope doesn't really have time to recover. And what you also need to think about that you're dropping into the exact same position each time.
So the number of how many of these falls the rope withstood is written on the packaging, and that number is there mainly to confuse the new climbers into thinking that you can only fall for, let's say, 5 falls. But in reality, we never achieve such hard falls, and you can fall for hundreds of times before the ends of your rope starts to wear down. Also, while on average thicker ropes do have higher UIAA fall rating, some brands use bare minimum of 5 falls even for their beefy ropes. So as it stands for now, this fall rating is only an indicator that your rope is safe rather than how long is it gonna be safe.
Next test.
UIAA water test. Same setup as before for the Sheath Slippage, it's the same machine. The only thing that we're going to change here is that we're putting new bolts every single sample that we do.
So it's a one-time use product, unfortunately, not very sustainable, but if you wouldn't do it, the inside of the bolts would change over time because of the abrasion of the rope.
So these are some of the used ones, so it's full of fibers.
So the rope goes through the bolt.
Yes, and then as before, you have 3 bolts. One gets pulled down, this one gets pulled this way, and this one gets pulled this way.
One goes that way, one goes that way, and
this one goes down. So now you and I have to pull this back and forth.
Oh, and me as well?
Yeah, of course.
How do you do this alone?
I just run back and forth.
So I pull?
Yeah.
Oh, wow.
But try to keep it as level as possible.
Stop. And now follow me. Yeah.
This is a warm-up for climbing. You know what would be funny?
Mm-hmm.
I expected it.
So now we have more fluffy rope.
Yeah. And we do this to simulate a rope in normal use. We do not want to do this water test on a brand new rope because it would not be realistic. And then,
the fumes are delicious.
Now, 24 hours, 23 degrees, 50% humidity.
Another time-sensitive endeavor.
Yes, so now I'm going to take a sample, the one you and I prepared yesterday. Let's go.
Basically, it is important to
be fast on this one. Okay, so put my sample in. And I make sure that there's water running on top of it. Now I start my time. I'm checking the water flow per minute.
So it is not submerging the rope completely underwater.
2 liters per minute, plus minus 0.2. And then the water is running on top of our fuzzy prepared rope. And you see here, it's really important that your ends are sealed. Otherwise, the water will just, go in rather than stay outside with the dry treatment.
It looks like the end of the rope is pissing a little bit.
Yeah, a little bit.
And it's gonna take now 15 minutes. So we
15 minutes?
We can go for a coffee.
Okay, now our 15 minutes are done. I need to take it off, place it here, and just drop it.
That is funny.
3 times.
That is very funny.
Change. Do the same on the other side. Now I place it here.
And now
it's
we
time
wait.
to weigh it.
So what are you aiming for?
We usually are around 1%, maybe a bit less. To claim that it's a dry rope when you do this test.
She's good at this. What? She's really good at this.
Are we ready to go to the weekend?
Are we ready to go to the weekend? We're talking about the dry limits.
Sorry.
So yeah, usually to declare that your water...
Now, while digging through all the different manufacturer websites, I found out that there are a lot of different dry treatments with different labels. Sometimes the treatments are added only to the sheath, sometimes both the sheath and the core. And sometimes they are better for our planet and labeled as PFC-free. But just because the rope is treated with something, it doesn't mean that it's passed UIAA water repellent test. To have UIAA water repellent label, the rope needs to absorb less than 5% of water. And if you want to learn more about what happens when the water penetrates the rope, I have made a video showing exactly that, both in theory and in experiments.
Yeah. Shit, there's a lot coming out.
And as a side note, dry treatment not only blocks the water from entering, but also the dust, which can greatly increase the lifespan of the rope. We also tried washing the rope and see if that helps. So yeah, that's another shameless plug of my previous videos.
What the hell? Yeah, she's using the heels.
Hip mobility, people. Hip mobility.
You have shorter legs.
Hey, short leg shaving.
You can't even put your legs on the pedals.
Whoa!
I just did a wheelie.
I'm just doing a wheelie.
Do this. I need to lean more forward so I don't wheelie. I'm going! I'm going! I'm going!
It's going!
Sometimes I get impressed by the amount of people who watch my videos. When I'm making and I'm filming, I'm just here alone. And it's so hard to imagine so many of you watching this. So thank you. I appreciate it. It's super nice. And thank you for Mammoth for sharing all of these geeky topics with us. Yeah.